In this video, I am going to use the definition of my hyperbola to generate these points right here on the hyperbola, and then show that the equation for the hyperbola will be x squared over a squared minus y squared over b squared equal to 1. To generate the points for the hyperbola, so first pick any 2 points like this, horizontally aligned, and so let's call this one F1 and call this one F2. And so the distance between F1 and F2 in this case is 10. Next, pick the constant less than 10. In this case, I picked 4. And then next, what I want to do is find all points such that the difference between the distances from the point to F1 and the point to F2, that difference must equal to 4. So let's look at these 4 points. Now let's take a look at this point A right here. So here we have the point A, which is located at 5 and 10.5. F1 is located at 5, 0. So the distance from A to F2 will be 5 minus negative 5 plus 10.5 minus 0, and we get 14.5. So the distance from here to here is 14.5, and then the distance from A to point F1 is 10.5. So the difference will be 4. The same thing for point B. The distance from here to here is 14.5. The distance from here to here is 10.5. So the difference between the distances from B to F1 and F2 is 4. Same thing here. The distance from here to here is 14.5. The distance from here to here is 10.5. And therefore the difference between the two distances is 4. And same thing for this point, 14.5 and 10.5. And so that's what we want. We want all points such that the difference between the distances from the point to F1 and F2 is this constant 4. And the same thing for V1 right here. The distance from V1 to F2 is 3. The difference from V1 to F1 is 7. So the difference is 4. And then for V2, the distance from V2 to F1 is 3. The distance from V2 to F2 is 7. And therefore the difference is 4. And that's what we want. We want all points such that the difference between the distances from the point to F1 and F2 is equal to 4. And here are the other points. So all of these points so this point, the distance from here to here and the distance from here to here, the difference is 4. This point, the distance from this point to F1 and then the distance from this point to F2, the difference will be 4. And now, if we connect all these points together, then we have what's called a hyperbola. And these are called the branches of the hyperbola. And so the two branches open, one opens to the left and one opens to the right. And so once again, to generate the points on the hyperbola, first pick any 2 points horizontally aligned. So in this case, we picked 5, 0 and -5, 0. And then notice the distance between F1 and F2 is 10. Next, pick the constant between 0 and 10. In this case, we picked 4. And then generate all points such that the distance from the point to F1 and F2, the difference between the two distances must equal to 4. Then that's how we get the points on the hyperbola. Next, what we want to show is that for this hyperbola, the equation will be x squared over a squared minus y squared over b squared equal to 1. And so what is A, what is B, and what is C? A is the distance from the center, in this case is 0, 0, to this point V1 right here. So for this particular example, the distance here is 2, so 8 is 2. C is the distance from the center to one of the foci, or C is the distance from the center to F1. And this particular example is 5. And so B squared is just defined as C squared minus A squared. And so we will show that the equation is x squared over a squared minus y squared over b squared equal to 1. So once again, A is the distance from the center to V1. C is the distance from the center to F1. And now let's look at the distance from V1 to F2. So V1 is right here, and then F2 is right here. The distance from here to here is A, the distance from here to here is C. And therefore the distance from V1 to F2 is A plus C. The distance from V1 to F1, from here to here is A, from here to here is C, and therefore the distance from V1 to F1 will be C minus A. And so the distance from V1 to F2 is A plus C. The distance from V1 to F1 is C minus A. And so the difference between the two distances will be A plus C minus C minus A. So we get 2A. And so what that means is that for any point on the hyperbola, the sum of the difference between the distances from the point to focus 1 and focus 2, that difference will always be 2A. So pick any point. So we pick this point right here. The distance from this point to F1, and then the distance from this point, same point, to F2. So the distance from here to here, and then distance from here to here, that difference will be 2a. So any point on the hyperbola, the difference between the two distances will be 2a. And now let's show that the equation for this hyperbola with the center at 0, 0 is x squared over a squared minus y squared over b squared equal to 1, where b squared is defined as c squared minus a squared. And so let's pick the point, any point on the hyperbola. So let's pick this point and call it point P with coordinates x, y. The distance from P to F1 will be x minus c squared, y minus 0 squared, and then take the square root. So this would be the distance from P to F1. The distance from P to F2 will be x minus negative c squared, y minus 0 squared, and then take the square root. And record that the difference between the two distances must equal to 2a. And so we have the difference between the two distances is equal to 2a. For this particular point, we can see that the distance 2 is greater than distance 1. But if we take the absolute values, it's going to be 2a, it'd be positive. And so here, assuming that d2 is longer than d1, then this quantity is larger than this quantity. And so if we take this quantity and then minus this quantity, it'd be equal to 2a. And so this quantity would be positive, so the difference here would be positive, since the length of this segment is longer than the length of this segment. So we can just drop the absolute value. And then we just use algebra and then just work this out like this. And then it will come down to x squared over a squared minus y squared over c squared minus a squared. And now set b squared equal to c squared minus a squared. And then we get x squared over a squared minus y squared over y squared over b squared equal to 1. And so the equation for this hyperbola is x squared over a squared minus y squared over b squared equal to 1, where b squared is c squared minus a squared. Once again, a is the distance from the center to the vertex, c is the distance from the center to the focus. And then notice that b squared is c squared minus a squared. So we have b squared is equal to c squared minus a squared. Note that a will always be less than c. And since we have b squared is equal to c squared minus a squared, b will always be less than c. And so if we represent the distance from here to here as b, then we have a, b, and c. And so here's A, B, and C. And now let's draw this rectangle. We call it the principal rectangle. The distance from vertex 1 to vertex 2 is 2a. We call this the transverse axis. The distance from here to here is b, and so from here to here will be 2b. And we call this the conjugate axis. And now let's draw the two diagonals of the principal rectangle. These are called the asymptotes. So the equation for this asymptote will be plus b over a times x. The equation for this asymptote will be negative b over a times x. And the center is at 0, 0. So here we have the graph for the hyperbola of x squared over 4 minus y squared over 16 equal to 1. So here a is 2 and b is 4. So now let's vary a and see what happens to the graph. So here's when 8 is 3, 8 is 4, 8 is 5, 8 is 6, 8 is 7, 8 is 9, 8 is 10. And now let's vary the b and see what happens to the graph. So here we have the type that's x squared minus the y squared. And now let's do the type that's where we have the y squared minus x squared. So this is the equation for y squared over 4 minus x squared over 16. So in this case 8 is 2 and b is 4. So again, let's change the a, so 8 is 3, and see what happens in the graph. And now let's vary the b. And here we back at y squared over 4 minus x squared over 16 equal to 1. And that's the end of the video.